Our final video for Chapter 1, which is Chapter 1, Section 4, this is the final video of Section 4, deals with the other two sets of identities that we're going to be using throughout the course. They are the Pythagorean identities and the quotient identities. So we're going to discuss how to derive these values. Okay? So, here we go. If we start off with x squared plus y squared equals r squared, which is our Pythagorean identity for our generic picture, and we take all three of those terms and we divide them by r squared, we divide all three of those by r squared, that is going to give us x over r squared plus y over r squared equals 1. Now, from our definitions, x over r is cosine. So that's cosine squared of our angle. Y over r is sine. So that gives us cosine squared plus sine squared equals 1, which is our first Pythagorean identity. There are a total of 3 of these because we could take the original equation and divide it by any of the 3 terms. So we divided by r squared to generate that identity. So now let's divide by x squared. So if we divide x squared, everything by x squared, then we are going to have 1 plus y over x quantity squared equals r over x quantity squared. Well, that's 1 plus y over x is cotangent squared, and r over x is cosecant squared. So there's a second Pythagorean identity. Okay, if we do the exact same thing one more time, only this time we divide by y squared. Hopefully by now we see how this works. If we divide by y squared instead of x squared, that would give us x over y squared plus 1 equals r over y squared. Well, x over y, that's tangent, plus 1, and r over y is secant, giving us our third and final Pythagorean identity. So we have 3 Pythagorean identities. These are going to come in handy on occasion. Specifically, the first one, cosine squared plus sine squared equals 1 for any angle, is extremely valuable in solving problems. But we just needed to derive these for now. We're not going to do anything with them yet. All right, the other identities that come up in this section are the quotient identities. There are 2 of them. Okay, they're formed by taking our basic trig functions sine and cosine and dividing them. So if we take sine and divide by cosine, okay, sine is y over r, and cosine is x over r. Now hopefully we know that when we have a complex fraction, that is essentially dividing fractions. So what we do is we multiply the bottom and the top by the reciprocal of the bottom. We discussed that at some point earlier in the chapter. All of the bottom, that's not how you spell it, cancels. And leaves us on top here, the r's would cancel as well, leaving us with y over x, which is tangent. So that allows us to say that tangent is sine over cosine. And if you've done any trig in your algebra classes, you may have already known that, but you've probably never seen it derived. If we do the opposite, if we put cosine on top and divide by sine, then we are looking at x over r divided by y over r. Same approach, multiply by the reciprocal of the denominator, which causes the entire denominator to cancel. The r's would cancel as well, just like they did in the top problem, and leave us with x over y, which is cotangent of theta, allowing us to state that cotangent is equal to cosine divided by sine, which is our other quotient identity. Okay? Now we're going to look at the problems that we would use this for. They're a little bit difficult to grasp early on. We're going to do 2 of them here in these notes, but you're going to need to make sure that you're doing your homework on time so that you're ready for the quiz. So again, we've developed 5 trig identities. We've got our 3 Pythagorean identities on the previous page. 1, 2, 3. The stuff in the boxes. And we have our 2 quotient identities here that relate tangent and cotangent to cosine and sine. So, here's the problem type that we're going to be looking at. Find sine theta and tangent theta, given that cosine theta is negative root 3 over 4, and the sine is greater than 0. We're not going to use that part just yet. So what we do is we need a trig function, a trig identity, that relates sine, cosine, and tangent. So we're going to use our Pythagorean identity that says sine squared theta plus cosine squared theta is equal to 1. And we're going to start with that. This is an equation that only has one unknown in it. We don't know sine theta. So we leave it as sine squared theta. And instead of cosine squared theta, we plug in the value from the directions. Negative root 3 over 4 squared equals 1. When we square the fraction negative root 3 over 4, make sure you put parentheses in your calculator. You should get 3/16. That equals 1. We would then subtract 3/16 from each side of the equation. Remember that 1 is 16/16. So when we subtract that, we get sine squared theta equals 13/16. We take the square root to get rid of the squared, and we get that sine theta is either positive or negative root 13 over 4. Now I know what you're thinking. What positive or negative? What do we do with that? Well, that's where this comes in. We're told sine is positive. It's greater than 0. That means positive. So that means that we only keep the plus, not the minus. So that tells us our final answer for sine, which is that sine of theta is root 13 over 4. Now that we know sine, we need to figure out what cosine is. Or I'm sorry, what tangent is. There we go. So there is where we use our quotient identity. Tangent of theta equals sine of theta over cosine of theta. Plug in what we know. We know the sine and the cosine. So that gives us that the tangent of theta is root 13 over 4 divided by negative root 3 over 4. So that's a complex fraction. Let's get rid of the complex fraction first. We're going to multiply the bottom and the top by 4 over the square root of 3. I'm going to think you're going, why don't we multiply by negative? You can, but really this negative is going to slide out in front of the fraction. So we really don't need to. Okay? We're going to multiply the bottom and the top by 4 over the square root of 3, because whatever we do to the bottom, we have to do to the top. All of this cancels on the bottom. On the top, the 4's will cancel, and that will leave us with negative root 13 over root 3. Now we're almost there. We still have a root in the denominator, so now we have to rationalize the denominator by multiplying the bottom and the top by the square root of 3, which gives us that tangent of theta is negative. Don't lose that negative. Okay, it's still there. Root 39, which does not reduce, over 3, which is our final answer for tangent. So step 1, we find the sine. Step 2, we find the tangent. Let's do another one. Find sine and cosine, given that tangent is 4/3 and theta is located in quadrant 3. Now this is going to take a little bit of a trick because we know tangent, but we do not have an equation that relates tangent directly to sine or cosine. We have one that relates tangent to secant, so we can find the secant very easily. Let's do that. So we start with 1 plus tangent squared theta equals secant squared theta. I know what you're thinking, like, why would I need to know secant? It doesn't ask for secant. Well, secant is the reciprocal of cosine. So if we know the secant, all we have to do to find the cosine is take the reciprocal. So this is really finding cosine, not secant. Plug in what we know, which is that tangent is 4/3. 4/3 squared is 16/9. Square the top, square the bottom. Add 16/9 and 1. Remember that 1 is 9/9, and then you add the numerators. That would be 25/9 equals secant squared theta. And take the square root of both sides to get rid of the squared. Should be plus or minus 5/3. Which means that the cosine of theta is either positive or negative 3/5, the reciprocal. Now we are in quadrant 3. In quadrant 3, cosine is negative. So our final answer for cosine would be negative 3/5. Okay, so now we need to find the tangent, now that we know the cosine. So we go back to our quotient identity, which says tangent is sine divided by cosine. Plug in what we know. Tangent is 4/3. And cosine is negative 3/5. Now think of this as a one-step equation. To get sine by itself, I need to multiply by negative 3/5. So I'm going to multiply both sides by negative 3/5. That will cancel the fraction on the left. The 3's will cancel on the right and give me a final answer for sine of negative 4/5. That does it for the Chapter 1 notes. Hopefully you have found these videos helpful and will continue to use them throughout the semester.